I believe this presentation was titled Workbench to Visual Studio, but we thought it would be more appropriate if we called it Traditional Synergy in Visual Studio and Migrating from Workbench, because we're going to give you an introduction to what we've built as the traditional Synergy integration in Visual Studio and talk about migrating from Workbench if you've already got Workbench projects. So when we set out to build the traditional integration in Visual Studio, the real thought was it's one IDE to rule them all. We want you to be able to do all of your development in one place, to have the full Visual Studio experience for all of your Synergy development and have it feel like the rest of your tools that you and the rest of your developers are used to using. We wanted to set out to have really functional projects inside of Visual Studio. We know a lot of you have oodles and oodles of mainline programs, so we created a mainline project type to build all those programs in a useful and meaningful way and be efficient during your development process. We added cool features based on PSG suggestion, like being able to right-click on one of those programs in your project and say, I want to debug this one. You don't have to fish through dialogues to try to figure out which program is going to start in order to debug that project. We've also done a lot of work to live inside of MSBuild. So all of your Synergy source is going through our build tasks to build your software with MSBuild. You can do it inside of Visual Studio. You can do it outside of Visual Studio. We have all of the intelligent build dependency that you expect in MSBuild. So it knows when your sources have changed, when your libraries have changed, and only builds the things that it needs to build. You can do all the different platform configurations, all of the different debug configurations, and you can build your own arbitrary configurations. We also have project templates for all the things. ELBs, OLBs, if you have a single application, standalone, and of course the mainline project type, and we'll talk more about that. We also have some new IDE enhancements inside of Visual Studio that are built with traditional Synergy development in mind, and we will talk about that a bit more. Like a reference manager that understands your Synergy logicals and knows how to reference ELBs and OLBs from them. A common properties dialog that lets you define all of your environment in one place and use it across all of your projects, so no more tweaking all of the projects just to get set up. And we have a lot of prototyping enhancements. We've talked a bit about what's gone into prototyping in past slides, but we will really dive into what changed during this presentation. It got a lot of bug fixes, for starters. When we got our hands on prototyping, we realized that there were problem areas that none of you could have solved when you were trying to use the tool. So we put in a lot of work and made the rest of the compiler team put in a lot of work to make prototyping a much better experience. And to help you out, it's a lot more relaxed. You can specify some new key relaxed options to make it much easier to prototype your code. And we can do that stuff inside of Visual Studio so that you can get up and running very quickly. It also drives the IntelliSense that we're doing in Visual Studio. So fully prototype projects are important in order to have that high fidelity IntelliSense experience. And we've got solutions for circular references in traditional ELBs, and we'll talk more about that as well. We also have a migration tool, which Steve has talked about a little bit, but we will go into much more detail on that. And if you've got Workbench projects already, it's going to get you there very, very quickly, and you'll find out more about that later in the slide deck. So definitely one IDE to rule them all. We are big fans of Visual Studio. We use it day in and day out. We know a lot of you, when you've experienced using Visual Studio, have enjoyed it. Synergy.net development is great. And we are also going to present some more features of Visual Studio, whether Synergy or otherwise, tomorrow in our Visual Studio features presentation. So be here for that. So let's go on to project templates. We've got the multiple mainline DBR. It's going to be pretty straightforward. You just add all of your programs. You define your build and compile settings for all those programs, and the references that you specify will apply to all of those programs. Executable library, self-explanatory, object library, traditional application, which is not really applicable most of the time, but if you have a single program and you want to specify other subroutines and everything and have one project that contains it, that's what it's for. And in the future, we want to add more things. We focused really hard on delivering the basic functionality, the core functionality, but we want to add more. So .NET Component Projects, a project type to really wrap repository usage and experience, so you could just do add ref and pick the repository project. GenNet, script compiler, other things that you want, give us the feedback as soon as you can, and we will see about making this even better. Let's dive into mainline projects a bit more. It's a collection of mainline programs. Same compile options, same link options, including references, we've stated all that, built separately together. So we generate the compile and link for everything in that project, but they are all separate entities. They all get built separately. And if only one of them has changed and you just do a build again, that's the only program that's going to get rebuilt. We don't want you to waste forever rebuilding all of your 1,200 or 2,000 or even more ridiculous numbers of programs in a single project. Only build the ones that have changed. We can detect not only the changes that have occurred just in the sources there, we detect when the libraries that you've referenced have changed, we detect when includes have changed. So there's a lot of work going on to make sure that that happens smoothly. You can set the startup object for the multiple mainline project type. So if your frequent usage is, I only ever am going to start this one program, you can go into the menu and you can select which program is the startup program. And that way you have that F5 debugging experience, so you can just say start debugging or start without debugging and always get the right one. We also made it so you don't have to go into the dialogues. You can right-click on one and say, this is the one I want to start with. And of course, you can always just right-click on one and say, start that one. We wanted this to be really intuitive for your traditional Synergy development. And I think you're going to like it. With new project types comes new property pages. We wanted this to be a similar experience to what you get in Synergy.net, but tailored more for your traditional Synergy development where applicable. The application page lets you specify what the output name is that's normally passed to the linker. You can set a working directory, so if you have sources that do includes from the local directory, all that stuff can work in the compiler. These also take logicals, so you can specify a logical on that working directory field and just have it work. Output type field is really just to control mainline or ELB or OLB. If somehow you accidentally create an OLB project, you can swap it out. And that startup object field only applies to the mainline project type. That's where you will specify which program is the startup program for that project. We also have a new build page. You can set the platform target for that configuration. You can set the target Synergy runtime version, which, as stated, goes all the way back to 9.5.3 for traditional. And that will control how that configuration in this project builds. We also have that IntelliSense language version dropdown. We are working on making that an even better experience, but that shows the same version history. When applicable, we will try to only display things in IntelliSense that are relevant back to the version that you're targeting. That's not perfect right now, but we will definitely be improving it as we go. The output path field is defining where you are building to in this configuration. That also accepts logicals. So if you have like an exe or bin colon, that's the place to put it. And that drop down at the bottom is the debug or debug full, which is a new switch in traditional right now, which essentially is the full debug output. There's also optimize in that drop down for your release configurations. So that should be pretty familiar from Synergy.net. And then the compile page is this big mess because we have a whole lot of compile options. We did do some cleanup here to try to make it easier to use. And this also has the new Q-relaxed options that we've briefly touched on. Check it out. Let us know if you've got ideas, but I think everything that you want will be here. This has as many or more options than Workbench did, and we tried to make it more self-explanatory. They've got good descriptions. They show you both the Q switch and the regular switch if you're more used to that. And those Q-relax options do have hover over help text, since they're not really self-explanatory.
And if you are missing an option, down at the bottom, there's
yes.
that other options field. So there's always the escape hatch of you can put whatever you want there, and it will get passed along to the compiler.
Yeah, if we miss something, you can always put it there, or if a new option comes out and we haven't added it to the UI yet, just Just put it in that field and you should get the behavior. The environment variables page is pretty self-explanatory. You set the name on the left, you set the value on the right. These do accept the MSBuild style variables. So, if you want something that's configuration specific, you can say $configuration, $platform, that kind of stuff, and get paths based on those things, like your bin debug x86. We pre-populate those paths just to try to give you the behavior, like a build behavior, which is I can build 64 and x86 separately. So you're no longer trying to build two different platforms into one directory structure. And we do some work under the hood that if you want to do logicals that way too, we try to make sure that we're not stomping over the same directory for the same logical. Also, in your environment variable specifications, you can do logicals as well. Those will get translated at build.
And you can nest the Synergy logicals specifically, and they are order dependent. We process this grid that you're seeing on screen right now. We process it from top down. So something that's defined above you, you are able to reference that as a Synergy style logical. So the Fred there we have it as the second one is referencing the definition from above it. You can keep nesting and building those up as you go down. That doesn't work for the MSBuild variables. Those don't change based on what you're setting here, but the Synergy logicals, it does work.
Very important that the MSBuild logicals do not nest well. They all get resolved at the exact same time, so you're not going to get the paths completed the way that you expect if you nest them. And of course, we have a new dialog, which is actually going into Synergy.net as well. This is our common properties dialog. It's essentially just a rehash of that environment grid, which will get applied to all projects that opt into it. If you want to use it, just go ahead and click into common properties in the property pages, check that box, and it pre-populates a common.props file, which is really just another mini MSBuild project that defines environment variables that can be shared. And this stuff, it works great. PSG has done a ton of testing for us to make sure that this is actually a good experience. So if you have common environment variables, which almost everyone uses the same environment across all their projects, this is really the way to go. Enjoy.
Right now, it only does environment variables. From a user interface perspective, it only does environment variables. But we're trying to figure out how to make a good UI here that isn't just cluttered, duplicated mess, so that you can put other sorts of common properties in that are shared across all of your projects. Watch this dialog. It will change as time goes forward.
The environment variables is really just our first iteration. It seemed like a good starting point of things that people share a lot that we could really nail down, and then we can continue to iterate on this and go forward.
Can you explain that environment variables override common properties?
Correct. So the environment variables dialog, the regular environment variables, take precedence over what is defined in common properties. So if you have all this common environment, but one project needs to specify a different value for the logical, you can overwrite it. And it's order dependent, the way that the common props are included. As long as you don't go edit the project file yourself, it will always be that the environment variables will take precedence over common properties. So IDE enhancements, we do have a couple of changes to really nail down the traditional Synergy experience. The reference manager dialog, when you right click and do add reference, that works really well in .NET because it's a .NET dialog. It understands assemblies and it understands your projects and it knows how to search for an assembly. That doesn't really work for traditional Synergy, so we had to do some work here. The project references, it's only going to show you the types of projects that are meaningful to this one. So if you're in a traditional Synergy multiple mainline or ELB project, it's only going to show you ELBs and OLBs so that you're not trying to reference your .NET projects accidentally. Also, we've added a separate tab here into the reference manager dialog, which understands the logicals that you've defined in environment variables and common properties. We are able to go scan the directories that are specified there to locate ELBs and OLBs from your real Synergy environment. And so we will show you in this page of the dialog that all the ELBs and OLBs that we could locate and give you the path based on logical that you're actually going to reference. You're no longer trying to get a weird hard-coded path to an ELB and just having it fail at build time, fail at runtime. We want this to be good. When you reference these ELBs and OLBs, you can have the confidence that they're actually going to get that logical reference and work correctly. As you can see here, we've pre-populated also the DB Elder, WND, and RPS lib. If there's something that you think we're missing here, let us know, but this should cover most of your common usage.
So all of this work is built on top of MSBuild and build tasks that we've created for traditional Synergy. So one of the really nice things, really nice developer experiences around MSBuild is the idea that I can have a whole lot of different configurations and they will not step on each other. They have their own intermediate directories. I can build things, I can link things. Files end up in the right places, and you never end up with a mismatched, I checked this option in this configuration, and I checked an incompatible option in this configuration, and someone built this one, and then someone built this one, and I ended up with a really messed up built DBR or whatever that just doesn't work. So configurations are kept separate from each other. And we pull some tricks in order to make that actually work in a Synergy traditional environment. And a lot of them come down to link logicals and making sure that files are in essentially the right folders for the link logicals to still end up working properly and the way that you expect. When you build a Synergy traditional project, we're going to default output that DBR or that ELB or OLB to your project folder, bin, the platform that you're building, which is probably x86 or x64, and then the configuration, which is probably debug or release, but can be arbitrary. So in the sort of default case, that's bin x86 debug. The configurations are completely arbitrary. Despite the fact that they say debug and release on them, that's like barely scratching the surface of the sort of configuration things that you can do with it. Thanks to sort of some of the new features that have made it back into the traditional compiler, like qdefine, you can dramatically change things in what you're actually building on a per configuration basis. And hopefully that will save people from having to have a bunch of different environments on their machines that are set up for this customer's version of my code and this customer's version of my code and this other customer's version of my code, and make sort of developing that a little bit easier and more seamless. You can also specify the runtime version on a per config basis. So you can imagine having a debug 10.3.3 and a debug 10.3.1 build, where the compiler will enforce that when you're building this one, it's making code gen that's going to run on 10.3.1's runtime. And when you're building this one, you get to take advantage of other features that maybe you if-def in, like, oh, instead of doing this read-s loop over the entire file, I can have this super awesome select join statement or something like that without impacting the builds that you still do that target down-level versions. Marty is going to kick off it's sort of a dummy project. We basically just made a project and shoved a whole ton of code into it so that we could make it take a long time. Marty's going to run that, and it takes a while, so we're going to switch back to talking about stuff. And then we'll come back, and it will have taken a really long time, and then we'll show you how to make it go faster. So MSBuild is a dependency-aware build system. So you are declaring things like references, and the relationships between the different projects are there. So that means that we can do really simple timestamp checking against all of the files that you're working with to say, yes, this needs to be built. No, this doesn't need to be built. No, I do not need to spend 30 minutes rebuilding your project just because one file in a mainline somewhere got changed. And it's smart because it knows everything that you are doing. It can actually genuinely figure out what needs to be built. In addition to checking timestamps against ELBs and OLBs, and checking that the source files have appropriate timestamps as well for their outputs, we actually added some stuff into the compiler to dump a big fat list of all of the files that your source file actually included. So we know every single bit of source file dependency that you have for any given project that you've built. Even if 10 layers of include deep, you change one character in this file, we know all of the files that are impacted by that include that was 10 layers removed from the file that's actually about to get built. So it's a pretty nice experience to just change something in an include, and only the files that need to be built that actually use that include end up getting built.
I think we actually have a demo for that, don't we?
I think we might have a demo for that.
So I have this nice little arbitrary test application, perfect for this purpose. And I also have something that's going to track the timestamps of the things inside of my final build directory. So if I build this project right now, nothing is happening here. If I rebuild it, we should see that the timestamps have changed and it's good to go. So this one mainline application is referencing an ELB, an OLB. It's got a couple of programs in it. So if I go over to the ELB and I make a change and I just do a build here, I should see changes again. I do a build again, nothing. Let's let that finish, there we go. Yeah, nothing happens. So to actually illustrate the include bit, here's one of those two programs. It's got an include of Inc1. Inc1 includes Inc2, Inc3, Inc4. And that finally includes a record. So if I just make a change in here, it has actually rebuilt the two things that are including that top include, which does the next include and the next include and the next include. So it's not a grandiose demo, but it is showing that we really are processing all those includes, and we are only actually building if something has changed.
What this should allow you to do is to stop thinking about, I changed this file, what part of my build system do I need to go to the command prompt and kick off? Ideally, you can just press F5 and it'll launch whatever you've got set up to launch, and it'll build whatever needed to be built in order to launch that thing. But it gives you sort of solution-wide build. I press a button in one place and a build comes out the other end. You can press a button in one place and rebuild everything, which will clear out all of the intermediate directories and rebuild all of your files. You can clean it. So an interesting use case for cleaning your project is I'm about to hand someone else via SneakerNet the contents of my project, and all of these ELBs and DBRs in various places take up a bunch of space, and I don't want to spend a bunch of time putting it into this zip just so that I can hand it to them. Press clean, your project is suddenly like 90% smaller, and it's a whole lot faster to send that zip over to someone. So remember we kicked off that other build that I said was going to be really slow. I'm going to switch over to wherever that command prompt went. So we can see that that finished, and it took 2 minutes and 54 seconds. But we can do better. There's about 20 projects in here, and what you saw take 2 minutes and 54 seconds is building the first project, building the second project, building the third project, fourth, all the way down to 20.
It's a clean, should be a clean command there. There you go.
So I deleted everything so that we're gonna pay the full build price here. So I put 2 characters on the end of this command line. It is a /m, and it tells MSBuild, hey, you understand everything about all of my 20 projects and their dependencies. Wouldn't it be cool if I could just, however many CPUs I have in my machine, build that many projects at once? So yes, that would be cool, and that's it starting. That actually shouldn't take all that long.
Yeah,
I think
less than 2 minutes.
Yeah, it's significantly less than 2 minutes. So this laptop is a 2 real core processor. It represents itself as 4 cores, so it's not quite real 4 cores, but it's at least 2. So we should be looking at least twice the speed improvement here. And in theory, I can actually manage to talk through this entire build because it really actually shouldn't take that long. And in your sort of more complicated environments where it's not just a bunch of dummy text trying to make the compiler run slow, it ends up actually being very helpful for MSBuild to know, yes, I need to build this ELB that absolutely everyone references, and then I can build everything else in parallel. So it's not like it will not run into a scenario where I need to run 4 builds at once, so I don't care that I don't have the dependency built yet. It won't ever do that. It'll wait until it has some kind of part of the dependency tree that it can run multiple branches at the same time. We're on 15 now, 16. Someone just finished 18. And I think we're almost done.
Just about.
Just about. There, and it's done. A minute and 44 seconds. So pretty close to 2 times faster than just shy of 3 minutes. On your machines at your office, where they are not, in theory, laptops, they have between 4 and 8 cores, you can actually end up getting even bigger performance improvements. And for Ace sitting back there with his build servers, in theory, you can just feed this as many cores as you have, and it'll just make your stuff go faster. So hopefully everyone's happy with that.
To note, there is presently no way to get this multi-core build behavior inside of Visual Studio. Microsoft has not added that yet, but just that /m switch on the command line is the way to go if you're doing real builds and want to get better build performance.
Right, so you'll see, and you have seen in quite a few of our slides, this $paren syntax for MSBuild variables. MSBuild variables are really handy for creating projects and solutions that move around. So a big problem that people end up having is they set up this build system and they end up with some hard-coded paths, and when some new hire comes on and you're trying to set up their machine, you go, okay, you need to make a folder on C called Joe's development environment, and then you need to put a folder inside of that called my company name, and then you put all of the source files under there, and then it'll work. But you have to set up some of these environment variables, and they're based off of that folder that you picked. So MSBuild is sort of gonna solve that for you if you take advantage of it, because there's a bunch of common variables that you can use that are super useful. Solution dir saves you from having to have that hard-coded C Joe's dev folder, because it's basically just going to say wherever that solution file is at today, that is the development root. If I base everything off of solution dir, no matter where I put that solution on disk, everything will just work, right? It'll all be relative off of solution dir, so as long as I don't change the relationship between the .sln file that you have for your solution and the actual contents of your project, everything will just work. Project dir is very similar. When you want to figure out, this is where my project is in the hierarchy, I don't want to think about its relationship between the project folder and the solution folder, so I'll just say, yes, I know that it's in my project dir, I can root off of project dir. Configuration and platform are, again, pretty useful, especially when you're trying to come up with, this is the output directory that I want to dump all of my files into, because you don't want to mix and match platforms and configurations and end up with, I have 50 DBRs that work on x86, and I pressed build on the 64-bit side, and I ended up with a folder that has a bunch of 32 and a bunch of 64, and which one you click on, maybe stuff doesn't work. That would be sort of bad. If you keep those separate and use configuration and platform MSBuild variables, your life will be a lot happier. So on the slide, we have even more common variables, so that second link down there is the shortened version of the one above it, just in case anyone is sitting out there and wants to quickly type that into their browser. It's a lot faster to type the bit.ly link than the very long MSDN link above it. Right, so prototyping.
Prototyping is something that I'm sure plenty of people are nervous about, that we are putting a big focus on it in traditional and Visual Studio. But we really did set out to break DBL Proto in every way that we possibly could. We have a fairly substantial collection of customer projects on site, and we definitely set DBL Proto through its paces. I'm sure we've missed some stuff, but there are so many fixes in 10.3.3 that with a couple of those QRelax options, you should actually be able to use it now.
Right, so the really important QRelax flags that you will potentially care about are QRelax param AD, which essentially says, it's sort of a dangerous switch, but hopefully you all know what you're doing. If you turn that on, it means that prototyping will not generate errors anymore when you pass an alpha to a decimal. So at runtime, if that alpha has ABCD in it, bad things will happen if you try and add ABCD to 12, right? Terrible things. You shouldn't add ABCD and a number. In a lot of cases, your code is coming from a time period in which maybe there weren't decimals yet. So your data type is alpha, and the contents of it are 1, 2, 3. So it's going to add just fine to another 1, 2, 3. There's not any issue. You've paid attention over the years, and you've made sure that you haven't passed ABC into this parameter. So if you tell the compiler, please get off my back about this passing an alpha to a decimal, it will do that. It will stop giving you errors. It'll still put out warnings, because we really do think that the quality of your code will improve if you actually don't pass alphas to decimals. It is to your benefit to not do that, because as much as we're all very, very careful, I think at least I've made a few bugs over the years writing software. So
Really?
it's possible to think that you've made sure that something's working and have it actually not. So the next one is a little less dangerous and a little bit more convenient for people who have large Exoserver Plus projects that they're trying to build inside Visual Studio. A lot of times, people essentially, they have a bunch of structures defined throughout their program, and then when they build the library that actually does the XF methods, they redefine those structures again, because that was kind of the only way that you could do it. But those structures are not actually the same structures that are defined inside of their actual program. They are the same layout, but they're not the same named structures. So before you add the QRelax param st, we would essentially say, no, struct Fred is not the same as struct Fred XF. You can't pass struct Fred XF to a parameter that expects a struct Fred. We added param st, and we make sure that the thing that you're passing is a plausible answer to the parameter that you're passing it to. But then we sort of get out of the way and say, yeah, this will work fine at runtime. We really don't need to give you a compiler error. All of this stuff being easier is really, really good news for all of you, because traditional in Visual Studio is essentially built on top of prototyping. So all of the IntelliSense is driven by good prototypes. All of the build dependency analysis stuff is essentially predicated on the prototypes being appropriate and declared and understood. But we do all the prototyping for you, and we handle keeping one project's prototypes separate from another project's prototypes and making sure that they don't intermingle when you haven't actually referenced that thing. And that was definitely a source of a lot of pain for people before, to the point that a lot of people that I've seen, a lot of environments that I've seen from customers, essentially dumped all of the prototype files into one folder. And then everyone just sort of referenced out of that folder, and maybe it works. Maybe you get the order of prototyping right, and you haven't stepped on any files, and you haven't got any ambiguities that are created by that. But maybe not. Maybe some voodoo builds around your build system, and you start thinking, yeah, I have to stand on one leg and hop and wave my arm, and then it'll build fine. This cleans up a lot of that for you, just by doing that separation of projects, references, and outputs, and it does a really good job of maintaining sanity. So some of you might have the gears turning in your head saying, oh, we're not putting all of the prototype files in one folder and running all of the prototype stuff first, and I have to declare references. What happens if ELB1 references ELB2 and ELB2 references ELB1? How do I make prototypes work for this? How do I make a build system that works for this? How is this supposed to work? This all works at runtime. The linker will fix this all up for you. There's no issue with it running, but how do we make a sane development environment that gives us all of these features, but I have these circular references? We came up with a fairly decent answer because we're controlling all of your prototypes, so we can start to make intelligent decisions, and you can make intelligent decisions as well. Oh, that's describing what I just said.
Yeah, that is describing what you just said.
It's a handy graphic.
Simple diagram just kind of showing the existing structure your ELBs might have where you are cross-calling between routines in ELB 1 and 2. And it doesn't matter right now because once you've linked it, it all works at runtime, right? But once you prototype, it does become a problem.
Right, so the solution to this is we call them proto-only references. So when you are prototyping a file, there's a bunch of errors that essentially don't matter and will happily generate the prototype for that file. And we're definitely taking advantage of that here because if there's some routine or some class that you need in ELB1 from ELB2, you can just say, all right, I will add this file to the proto run that I'm doing, and it'll generate all the signatures and it'll happily do its thing with prototyping, and it will build. So you're not actually doing a reference of the entire project, ELB2. You are just saying, I would really like to grab this signature worth of stuff and add it to my definition so that I know everything about this class or this function or subroutine or whatever, and just to make things build and have definitions rather than a full reference. And then when it eventually gets linked, it all gets fixed up exactly the same way that it does outside of Visual Studio, exactly the same way as it happens in all of your build environments, and it will end up just working. So there is one compile switch that you may end up needing. So you can imagine what I'm describing to you is essentially, hey, let's prototype this file more than once, and let's leave some prototypes around more than once. And that will cause duplicate symbol errors. Symbol already uniquely defined, I think is what the compiler actually spits out. We tried this and said, that doesn't seem to work, let's not do that. So we added a Q-relaxed allow dupe. So allow dupe will essentially look at the prototype, say, yes, this is the same prototype, and happily throw away the duplicate because it's exactly the same prototype and we can just move on from there. The way you get at the prototypes folder, if you're not using automated tooling to do it, that Marty will end up talking about in just a moment, is there's a folder on each project called prototypes, and you can just add a file to that folder node. And it's not like it's going to copy that file around. It's just going to be like a link. So it's relatively easy to do.
And so our final topic is our migration. I will just do a quick introduction to the tool right now. We have a tool called Syn2VS. It's pretty straightforward. It takes a parameter, which is your workspace file from Workbench, which it is going to deserialize and completely understand. It will figure out all the project references. It will figure out all the files. It will figure out your compile options. It knows everything about that Workbench file format possible. And so what it does is it takes all that information it understands and creates Visual Studio projects out of it. You can see that optional parameter DA, and what that is doing is we will run a dependency analysis on all the sources that we got out of that Workbench project. It takes a long time because we actually compile them, we get all of the symbol information, and we try to understand your actual hierarchy of sources and projects to discern where we might need to construct those proto-only references for you. So it's our methodology for determining the circular references and then kind of breaking that circular reference chain so you don't have to do the manual work. Of note, the converter understands your compile options, your references. It knows your link logicals. If in your link line you were specifying the logical, it's going to bring that across. And it also understands your synset environment variables. If you have those defined in your project open, it's going to bring that right across to your environment variable tab in Visual Studio to try to make the process as easy as possible. And down in the bottom, we do try to break those circular references for you. It's not perfect, but it will get you most of the way there. The idea is this utility is going to do most of this work for us, and we're going to work with you to resolve the other problems that crop up after this process has been completed. More on the migration, there is an upcoming Synergy e-news article also talking about the migration tool. There's a standalone doc available on the web with a brief introduction to the tool. That's the same thing that we did before. That bit.ly link is the same link if you want to get it right now. And of course, the workshop on Friday.
We're kind of over time, but let's, real quick, we think that Synergy plus Visual Studio makes you unstoppable killing machine. We figured what's a better unstoppable killing machine than a T-Rex, which only has one weakness. It's tiny short arms. So you can see we gave the T-Rex some grabber arms, so he no longer has short arms. He can reach everywhere and eat and destroy everything.
We do have a live Send to VS demo.
A live Send to VS demo. It's not very impressive because it takes like 1 second to run the thing, but I'm gonna run it anyway because hopefully you'll believe me that that's what this is actually doing. Right, so just real quick, this is an actual customer environment. This is FlexCon, which is here in the room today. We have a couple of these that we've actually done already, but this is the one that we're demoing at the moment. So this is their actual environment, and we have a batch file here that says generate VS solution. All this does is set a little bit of stuff in the path that we need, and then it runs the send to VS tool against flexcon.vpw, and then it exits. So I'm going to run that thing. So you can see all it did was run send to VS. Didn't really generate a whole lot of output that you can see on screen, but we ended up with a whole bunch of these .json files in this folder of varying sizes, and that's sort of the intermediate that we are keeping around for debug purposes on Friday, so that if things go badly, we can go peek inside those files and figure out why things went badly. That's why those are there, and I can just double click on this flexcon.sln. So here we have FlexCon inside of Visual Studio, and all the sort of colorization stuff is there. Projects are there. I can build and debug this thing now, but I have rambled on about MSBuild for entirely too long, so I don't think I actually have enough time to demo this all the way through. But we really have actually run very large customer projects. I think Steve told me this is something like 1,800 DBRs are generated from this. It's not small. It's a pretty substantial solution. So we think it'll work for your use case as well. Back to the slide.
Okay, thanks. Appreciate it. Great job.